G'day from Australia. My name's Ashley Davis. Welcome back to my coding live stream. You are watching me build a full stack application, which is the example application for my new book, Rapid Full Stack Development. Please feel free to reach out to me on Twitter and let me know what you think. You can find my Twitter handle on the screen. Before we start, I'd like to acknowledge the traditional owners of the land from which I'm broadcasting. I'd also like to pay my respects to elders past and present. I'm doing these live streams to support my book, Rapid Full Stack Development. You can see the webpage here, rapidfullstackdevelopment.com. Please come and have a look, see what you think, subscribe for updates if you want to keep track of what I'm doing with this book. Today we are continuing to build out the backend for the Photosphere application. I'll show you in a minute where we got to in the last session. But today what we're going to be doing is doing the database version of the HTTP GET route for retrieving an asset. And we're going to be building the HTTP GET route to retrieve a list of assets. I'm just going to be jumping straight into it today, but if you want to catch up on what happened in the previous live streams for this application, please come to my YouTube channel. It is called Code Capers. If you go to the playlists here and you find the Rapid Full Stack Development playlist, click on View Playlist, and you will see the previous sessions in this particular live stream. All the code for this live stream is being open sourced as soon as I can after I've written the code in my the organization for my book on GitHub, Rapid Full Stack Development. The repo is Photosphere monolithic backend live stream. So if you grab this code, there's some instructions here for how to set it up. So I'm continuing the code from the last live stream. I've already got Visual Studio Code open with my project in it. Having a look at my to-do list here, you can kind of see what I've done already. Uploading an asset, that is actually fully completed. We fully completed that in the last session where we added the code to be able to kind of add details to the database as we upload it. I'll show you that code in just a moment. And today what we're doing is upgrading the code to retrieve an asset, to use the database to retrieve the details of the asset and return it to the user of the API. We will implement the code to retrieve the list of assets that we have uploaded to the database. So the code that we worked on in the last session is that we upgraded this upload asset request handler, insert an entry, a record, into our MongoDB database. So we're storing the original file name of the asset and we're storing the content type. And this is going to allow us to fix a little problem that we had in one of the previous live streams where in the route handler, the HTTP GET route handler for retrieving an asset, we hard-coded the content type to image.png or image/png. Now we don't want to hard code that because we don't want to just be uploading PNG photos to this. We want to be able to upload any kind of photo or video asset to this this application that's going to help us manage our assets. So we can't hard code that. We don't want to hard code that, but we do now have that stored in our database thanks to the code that we wrote in the last session. I want to be able to look up the asset in the database. At a minimum, I want to be able to set this from the content type that we load from the database. Now, the first thing I need to do here is I no longer want to reference this by local file name. You remember in the last session what we did was we changed, when we upload our asset, we changed it so that instead of using the local file name, the upload file name, reference the asset, we are creating a database ID, so an asset ID. And we're using that in the local file name. So we're then storing the file. We're streaming the incoming body of the request to this file in the backend's local file system. Now, it should really store this in the cloud or somewhere that's not kind of in the local file system, but that's something that's we're not going to tackle just yet. So we're still just storing this in the local file system, but we're using the asset ID as the name. And you can see here from the previous session in the uploads directory under the backend, we've got some files here with rather bizarre names. So these are named after the database IDs for those files. And we don't actually need anything in here. We're just going to start this session fresh anyway, so I'm just going to delete what we had there. So the thing now is to say, we're not expecting the client to tell us the file name to get. This should be an ID, not a file name. Start with some testing. I'm going to go into my VS Code REST client script here and update my test. You can see here that we've got a little script here to retrieve an asset. So we're issuing a HTTP GET request to the asset route, and we're telling it to get the placeholder file. That's not going to work anymore because it's got to be an ID. So the thing we want to pass in now is an ID equals some database ID. Now, how do we know what that database ID is? Well, for one thing, we can just exercise. We can just exercise the upload, and we can generate a new asset ID that way. So I'm just going to send that request. Oops. it might help if I actually start the application first. I'm just going to first make sure I've got nothing outstanding to go up to be committed. Given that my rule is to always have working code whenever I commit, that means what I have here is working code, and I don't have any problems to fix starting this session, at least in theory. It doesn't always work out that way, but that's the way I try to work. So I'm going to run this in development mode, so npm run start dev. This is going to enable live reload. Whenever I change the code, my server is automatically going to restart. My backend server that I've got running locally here on my development computer is automatically going to restart to bring in those changes that I've made. You can see here as well that I'm running the instant development database, Instamongo, that I added into my development infrastructure in the last session. So I'm just going to send this request here to upload an asset. Cool, I should have one. I can see it here in my uploads folder. So that's just a quick way to test that that worked. I should also see a record in the database. Let me just open the database viewer. I'm using a database viewer called Robo3T. It's going to open connection to my database. Unfortunately, I can't zoom this in, so you can't see it any bigger than this. You can see here, so this is the asset that was just added. So we've got a recording of the asset in our database, the details of it. I'm actually just going to copy this. So I'm going to copy this database ID here that I'm reading using my database viewer, and I'm going to put that in there as the ID. This isn't a reliable way to get this, and in fact, we don't even have the code yet. So sending this request, it gives me a 500 because we are actually handling this route. We are actually handling the asset route. You know, I can't expect this to work just yet because I haven't written the code that actually retrieves, you know, this particular asset from the database. I just have to do one, to make this a little bit easier, I just want to do one thing over here. Now, inside this upload route handler, where we're uploading the asset, I'm allocating the asset ID, but the front end is going to have no idea what the asset ID is. So how does it know in the future, you know, what asset was uploaded and how to get that asset back? Well, one way we can do that is just change our response to be JSON, and we can just tell it the asset ID. So we're returning to the front end, as it were. We're simulating the front end here with VS Code REST client because we don't actually have a front end yet. But this is our way of telling the front end what the ID of the asset is that was just uploaded. Let me just test that. So I'm going back into my backend script, I'm sending that request. And you can see here that it's come back with the ID. So this is the thing that then we could potentially plug in here to retrieve our asset by ID. But I don't want to have to kind of I don't want to have to copy this over every time. I want an easier way to test this. And I can do it. I can do it with VS Code REST client. I would recommend that you read the docs to be able to do this. But I'm just going to quickly show you how I would do it. So the first thing is here that I want to name this request. And I'll call it name upload. This is the upload asset request, so I'll call it upload asset. That makes sense. Now what we can do after we execute that request is we can pull something out of the body. I can actually reference upload asset. It's given me an auto completion there that I didn't really want, but let's just delete that. So upload asset from the response, from the body of the response, we're going to pull the asset ID. So you can see that here. That's the thing that's returned over here. We're going to pull that out, and we're going to assign that to a variable called uploaded asset ID. We can then use that variable in our request down here. So we're saying we can upload an asset using this request. Out of the body of the response of that request, we can capture the asset ID into a variable, and then we can reuse that variable in subsequent requests. So I don't have to go and copy this ID and paste it in there. It just makes it a little bit easier for me. Now, of course, this still doesn't work, so we haven't written any code to do that. But I just wanted to get the test right first. It's a kind of manual test-driven development. It's something that you will probably start doing if you've learned test-driven development. You'll start applying that even to your manual testing, which is like, you know, creating your tests before you create the code to actually make those tests pass. So that's what this is. This is like a little manual test that I'm going to run to verify that my code over here works. We're back into the route handler now for retrieving an asset. Instead of getting the file name from the query parameters, I just want to get an ID, and that's going to be the asset ID. So I just did a refactored rename there. If you saw that, I hit F2, I renamed that variable, and it renamed it everywhere that it gets used. The next thing I need to do here is I need to do the database lookup based on that ID. And then once I have the details of the asset, I can just plug that directly in here. So I'm going to retrieve an asset from the database. It's an asynchronous operation, so I've got to await the result of that. I'm looking it up from my assets collection. I'm finding one record in my database, in my collection here. And the ID of it is going to be this asset ID, but loaded up into a MongoDB object ID. So this should give me my asset. There's a couple of different ways you can test that this is working. One, of course, is your old friend console.log. It's a great way to see what's happening. One thing I love about console.log in JavaScript is that you can literally log anything. Like you can pass anything into that, and it's going to give you an interesting kind of visualization of what that is. Another way to do it, because we're working with a HTTP route handler, is I can just return the whole thing via JSON. So I can say res.json asset. So we're just sending the whole asset object back to the caller, which means now I should be able to upload my asset and then retrieve an asset. Oh, server not running. Something's gone wrong. So the error I'm getting here is because await is only valid in functions that are asynchronous functions or marked with the async keyword. I've seen this error dozens of times, and that's the reason why I just don't have to think about. I don't have mental access to all the world's errors that could be happening in programming, but these things that I see all the time, I just instantly know how to fix them. I don't have to do any research or do any Googling or anything like that, only because this is just the kind of stuff I deal with every day. So the problem here is that my route handler function here isn't asynchronous. So I'm trying to use the await keyword in a function that isn't asynchronous. I can fix it easily by adding async. And if you're only just tuning into the live stream now and you didn't see the first one, you'll know that the reason that I can use async route handlers in Express is because I am using the beta version of Express.js version 5. So it's a new version of Express that allows us to to plug in asynchronous functions as route handlers. And if you remember back to the first episode, you'll remember me saying that. Let's save that. So I'll go back to here. I should be able to upload my asset now and then retrieve it. Yeah, so I'm seeing here the things that we saw in the database, the kind of things we saw in the database a moment ago. The original file name, which is coming from my placeholder test asset, and the content type, which we're automatically pulling from the incoming asset upload. If you remember where that comes from. So this is the route handler for uploading an asset. We're pulling the content type from the headers of the request. We're storing that in the database, and then we're exercising this route handler here for getting an asset. We're retrieving the asset from the database, and we're just sending that whole asset back. So what we see there is just what we just uploaded to the database, what we just inserted into the database relating to that particular asset. Now that isn't the full story. That isn't really what we want to do. Of course, we want to actually return the file itself, and we want to pull the content type from here, from the asset record in the database. So this should give us a nice little completion on this request handler here. Let's just give it a test. So I'm uploading the asset again, I'm retrieving it, and we get to see the asset here. But this time around, we're actually telling it which content type to use. So it's not hard-coded to PNG this time, is what I'm saying. We could have uploaded a JPEG, we could have uploaded an MP4 video, or whatever, as long as we're collecting that content type when we're uploading it. So we're collecting that again from the headers, we're storing it in the database, and then we're retrieving that record from the database, and we're sending it back when you want to retrieve the asset. So there's nothing hard-coded about this now, which is great. Now at this point here, I've got some working code, I've got a working upgrade to my code. I could go on and add the other thing that I want to add, which is retrieving the list of assets from the database. But I've got working code. I want to put that code in the bank before I break something. So I'm going to do that now. So I'm going into my Git UI here, which is fork, looking at the changes that I have made. And what I want to do here is every time I commit, I just really want to bring this home and drill this into you, that every time that I commit, I'm going in here and I'm checking the differences. Have you heard of talking to the rubber duck? So it's like what you do when you've got a programming problem, and when you explain it to the rubber duck that's sitting on your computer. I don't actually have one. I can just pretend that it's there. But you explain to the rubber duck that might be sitting on your computer what the problem is, and through that process of explaining the problem, you suddenly realize how to fix it. And this is kind of like that. It's like going through your code, self-reviewing it, explaining it to yourself how this works, and you'll be surprised how often this finds bugs and silly, embarrassing mistakes that you would never want to commit. I'm pretty happy with this. There's not much, one of the advantages of doing small Git commits, small changes, not just that they're easy to test, but also that they're easy to just review here and check the code and understand what's going on and understand that we're not checking anything in that's going to be bad for the product or embarrassing for us when we break the build for our teammates. And also just check your test code as well. So we'll check the changes that we made here to the VS Code REST client script. It all looks good. So I think we're ready for a commit here. So what is this? The route handler to retrieve an asset now referenced by asset ID and details are retrieved from the database. So that is committed. I will push that after the live stream. Let's go back to our to-do list just for a moment. So we've completely finished that function to retrieve an asset. We've only got one thing left to do, and then we've got the simple kind of core, the simple backbone for the Photosphere application. So this is actually going to be really easy. So this is like the easiest addition that I've made, but like I've done a couple of times already, I'm going to start by creating a test script for this. So this one here, I want to retrieve all assets. It's going to be a HTTP GET request. We're going to be sending it to whatever our base URL is. So if you remember, that's a variable I added a while back that says that we're targeting localhost on the port 3000. Now this could be anything. This could be a production web server. We could be testing a production web server using this as well. But we're testing our local development server and we want to get all assets. So it's as simple as that, I think. Now, of course, if I try running this, I'm going to get a 404 because I haven't actually written the route handler yet. So that's what I'm about to do. On our Express application, we're going to define a get route handler for the assets route. We'll make it async because we know we need that. We've got a request coming in and a response going out. Now, all we have to do here is a database lookup. We're going to do a find all on our assets collection. That gives us a database cursor. We can convert that to an array by calling toArray, which gives us back our array of assets. Now we can build up slowly if we like. So I'm just going to send a status code 200 to make sure that the browser is going to be okay with it. How do we test this? The first way is console.log. Console.log is your best friend. I'm just going to upload a couple of assets. So we've got 1, 2, 3. Yeah, there's a few there, maybe 4 or 5. I clicked a few times. Now I should be able to send this request. We'll get a 200 OK, and we should see the assets printed out on the console. So we've got a 200 OK. I'm just back in my terminal and you can see the results of the console.log. We've got a whole bunch of assets in our database now. So again, anything you need to look at, even if it's not coming out through a REST API or going into a database or anything, any intermediate computations or calculations or data wrangling that you're doing, just call console.log on it. That'll give you something interesting to look at and to verify whether it's working. Now I can also look in my database. If I go into my database and hit F5 just to refresh this, you can see that I've got a whole ton of assets now in my assets collection. Now we're not quite there yet because really what we want to do is we want to just return these assets to the caller. And we can do that simply by doing a JSON response and telling it the assets. And we don't need to send a separate status then. That'll automatically send a status 200 for us. So when we stop our development server, that stops Instamongo, which gets rid of our development database. So our development database no longer exists. And when we start up our development server again, we'll get a development database again, but it will be empty. So let's just verify that. If I go into Robo3T first and just do a refresh, I'm hitting F5 here to do a refresh. So there's nothing there yet. Found 0 records. That's a way to flush out your database if you just want to start again. It's just to restart your dev server. Do a retrieve all assets now. So I get an empty array of assets. And if I add an asset, I upload an asset here. So I'll click on my request to upload an asset. It tells me the ID there of the asset that was uploaded. I'll hit my retrieve all assets request again here. And now I see one asset in my list of assets. And I can keep going. So if I add 1, 2 more assets, I should now get all assets and see that there are 3. I would like to show you database fixtures, but I'm running out of time and I really want to finish up this series of live streams. So that's probably something that's going to come in a future live stream. And I'm definitely going to show you that in my book, Rapid Full-Stack Development. Now there's more that we could do here. There's definitely more that we could do. Some of the stuff that's going to be coming in the future is, for one, we're streaming our assets into our local file storage. When we deploy this application to, say, a Kubernetes cluster, that means that these assets would be stored in an ephemeral Kubernetes pod, which is definitely not what I want. That's a really easy way to kind of lose your data when a pod gets killed or something like that. It's great for development, great for starting out, and it's part of my philosophy. Just always do the next simplest thing that works. But for longer term production needs, this isn't going to work. So what we would do in the future for this is, instead of streaming to storage, like local storage, we would stream the file to some sort of cloud storage, like an AWS S3 bucket or Azure storage or something like that. And then when you're retrieving an asset, again, instead of creating a read stream from the file system, what we would do is we would retrieve that file from whatever cloud storage, like AWS S3. We were storing it there, we'd retrieve it from there. If we were storing it in Azure storage, we'd retrieve it from there. So you've got options where you can store it. Now, another thing here that you might have noticed is that I've got a little helper function here called stream to storage. As we grow this API, as we grow this code base, we're going to end up with lots of little helper functions like this, and they would be best to refactor those out to some other file. So maybe it deserves like its own file, or maybe there's a file devoted to kind of storage and streaming and stuff like that with helper functions. I would refactor this out to another file. I don't need to show you that in the live stream though. Another thing that's missing here that you might have noticed if you've had experience with this sort of thing, we're querying an entire database collection here of assets. That's a bad idea because, what happens when this gets to 100 assets? What happens when it gets to 1,000? What happens when it gets to 1,000,000 assets? So what we're missing here is some sort of pagination, which we should definitely have in here by default, and we shouldn't ever return like a full collection worth of data to the user, because that's a time bomb that's waiting to go off in future, probably in production when actual customers are using your product. So you definitely want to add some sort of pagination here. I'm probably going to come back and cover that in the coming months when I do a live stream on how to develop the front end for this. I'm going to come back and show you how to add pagination to this. Now, you might also be wondering about automated testing. We did a lot of manual testing. We made our testing a lot easier by using VS Code REST client here, where instead of having to kind of connect through a browser or connect or create a front end, we didn't need to create any front end code to test this, because we can test it from these HTTP request scripts that we've got here that you can see for yourself if you grab the code. So I would say that you always have to start with manual testing of some kind. Even if you are doing automated testing, it's great to occasionally do a run through of manual testing and just have the capability to be able to test manually anyway. I think is always a good thing. But ultimately, if you're going to be evolving this code over a longer period of time, or for other reasons, like if you need this code to be really reliable or really secure, you want to put a body of automated tests around this as well. And that's not particularly difficult to do. It wouldn't have been particularly difficult to create this backend using a pure test-driven development process. I haven't done that. I may do a live stream on that as well. I'm definitely going to do a live stream on automated testing. I'm just not 100% sure yet exactly what we're going to be testing in that live stream, whether it's this or another part of the application. So that's it for the Photosphere backend live stream. These live streams have all been to support my book, Rapid Fullstack Development, and you have been watching as I have been building the example code for the book. So in the book, what you're going to see is a more streamlined version of what you've seen in the live stream, and there will be live streams coming in the future for other parts of the Photosphere application that I am yet to develop. Thanks so much for listening, and I hope to see you again in the future.